I paid a total of £38, which equates to around about $50 for a faulty Xbox One S that doesn't power on. The listing states, Xbox One S, unit only faulty, no power. Let's see what's going on with this one. Looks like this has definitely been opened before, which doesn't give me great hope as usual. A few scuff marks that we can see on the Xbox. The condition of it isn't looking great, so I wouldn't be able to get that much money for this Xbox One anyway. Nevertheless, we're here to try and make a profit, and hopefully we're going to be able to do just that. It says no power, so we're going to test that first off. Do we get anything? Here we go. No. This button actually felt very, very spongy as well. What about the eject button? Nothing. Okay, so we verified that there's no power. Let's now take it apart. The grand reveal, how are we looking inside and under the hood? Not too bad, you know. Relatively clean, a little bit dusty, but that's pretty much it. It's a 500 gig hard drive, unfortunately. This isn't the 1 terabyte version. It didn't specify it in the eBay listing. But when I look a little bit closer, could be some signs of some sort of liquid that's fallen through the fan here and maybe onto the power rail of the console, which is down the right-hand side. Let's keep going. Wow, this is absolutely caked in dust. This is the power rail, which is where we should see power coming into the board, but I mean, how can anything come into the board with that? Look at it, man. What the flip? But this is replicated all over the board as well. It's not just on the power rail. The HDMI port at the top seems to be ridiculously dusty as well. And we've got all the ports over here as well. We just follow it around. You can see how much dust is actually on this board. Firstly, we're going to have to clean all of this up and then look out for any visible damage that might be causing a component to not work, perhaps. Looking a lot cleaner now down on this side. I just used a simple little paintbrush to loosen the dust. I didn't go hard or anything like that. I just loosened all of the dust and tried my hardest to put it into a carrier bag. So it's now just probably floating around my room. I can't see any components that look damaged with my eye, but I'm assuming it's going to be on this power rail. I've got my multimeter here in continuity mode, which is the mode that beeps when you put the probes together. This indicates a complete circuit. I'm going to put the black probe on ground just here, and I'm going to check on the 12 volt line, which is in the power connector. And there we go. So that's beeping. That means that we have a short to ground on the 12 volt line. I'm not great with the terminology, but what this could potentially mean is that there is a component that is dragging down that 12 volts, meaning that we're not getting power to the console. My next guess would be that because we've got the short on the 12 volt line, it's going to be a MOSFET down on the power rail. And for this next step, I'm going to put the meter into diode mode, which it now should be in with this symbol up here and the voltage sign over here. We're going to swap the leads. So I'm going to put the red probe on ground, and on the power rail, we have two types of MOSFETs. We've got this one here, which is a smaller one, and then we've got the bigger one. I'm going to put my black probe on the single line which goes to each of the MOSFETs. The reading that I want to see on this multimeter should be around 0.4 to 0.7 voltage drop. We'll start with the first one. What do we get? We get 0.67. That's a good MOSFET. Next one, 0.65. That's also a good MOSFET. I'm pretty sure there are so many other ways to check if a MOSFET's good or bad, so don't take this for gospel. This is just the method that I like to personally use. I was taught this by the coder. We go down to the next one on the line, and you see how we've got 0.016. When I say naught, I mean zero. I don't think Americans are used to hearing naught, but naught means zero. So 0.015, that's bad. So I go to the next one, just as an example, the bigger one underneath it, that can still read 0.6, so that's good. So we're looking at a tiny MOSFET here. If I put the meter back into continuity mode, and again, we switch over, we put the black probe on ground, and I go to this MOSFET on that same line, you can see we have a short to ground. It's 10.4 ohms on that single line, which it shouldn't be. If I go to another MOSFET that's good and I use continuity mode, my probe is actually on it now, but it's open line. I think if my meter shows over 50 ohms, it's open line, but I could be wrong. My terminology is horrendous, but that's why I do these videos. I like to make a fool out of myself, so you guys don't have to. What I then like to do is take good old Sharpie and just mark the MOSFET that's gone bust. It looks so pretty. Temperature wise, we're going to go for a straight 470 degrees Celsius with an airflow speed of 99% just to get the chip off. And now simply, this is a donor board, so we're going to grab the MOSFET from this one and put it onto the other board. Lowering the temperature to 450 degrees Celsius and an airflow speed of 50%. And now we clean up with the isopropyl alcohol. This is my favourite part. And there we go, so we've soldered on the new MOSFET. Let's see if we still get the short to ground on the 12 volt line. If I learned from last time, what I would have done is tested the short to ground on the 12 volt line whilst the MOSFET was off of the board. But I'm silly. Meter's in continuity mode again, mode that beeps. We put the black probe on ground. Do we still have a short on the 12 volt line? Here we go. No, we don't. We have no short on the 12 volt line. There's no beep. Will this now turn on? Before I test, I do want to just give the board a clean. You can see it's so dusty still. And the fact that we've got the old thermal paste, we want to clean that up, the greasy stuff, and just give it a bit of TLC. Right, here we go. I'm going to try and put it on in 3, 2, 1. Yeah. Wait a minute. Oh. It turns on for like a second, then turns off. So we get power. But it turns off. Interesting. Okay. We get the fan spin and we get the little beep. I wonder if something else is shorting it out when it's trying to turn on. This wasn't as simple as what I thought it would be then, hey. First off, I've got the power plugged in, the fan's still on, but I just want to test for voltages and make sure that we've got everything that we need to have. So we're going to have 12 volt because the console turns on. And I think without that, we'd be a little bit screwed, to be honest. There we go. So we've got the 12 volt there. Let's work our way down. So we need the 5 volt now, which is here. We've got 5. Do we have 3.3? We do. Do we have 1.8? We do. Do we have 1.1? We do. Okay, so confirmed, we have all of the standby voltages when there's power going to the board. I think as well, damaged ports, from what I've read up, can cause shorts. So I'm just going to carefully inspect each of these shorts, and I think as well, also the retimer chip can cause a console to turn off after it beeps on. So let's have a look. So I'm going to go over to the FLIR cam real quick, and we're going to have a look. Okay, so I've got the power in. There's my hand. I'm going to push the button, and I'm going to see if anything gets hot. Doesn't look it, does it? At all. I was really hoping this was going to be the thing that really helped us, but tiny little heat spot on the south bridge, but again, I don't think that's anything to worry about. I'm going to start by replacing the retimer chip to see if that fixes it. Just making sure that we're all good. I used the same solder that was on the board. It could have been a quicker and easier job if I had replaced it with leaded solder, but that looks fine. Everything looks connected. Nice. See what happens. Here we go. Is it fixed? Turns on, straight off. Yeah, it turns straight off again. Okay, so I think the retimer, the old retimer, was actually fine. What I'll do is I'll put that retimer back on the other board. What's next? I just want to update you guys on what I've actually been doing. I revisited the power rail, which is where originally the short was, and I was inspecting this exact part because this is where I replaced the MOSFET, and everything, again, just checks out okay. We get a good reading on the MOSFET itself. I've checked all the resistors as well, and they seem to be fine. Consistent amount of ohms between these ones and the other ones on the board. They usually, I think these ones are around 2. This one comes back as 2 as well, but again, they're all exactly the same as the other rails, and we don't have a short on the power rail. We changed the retimer chip. I've checked everything around that, seems fine. There's a lot of flux around here that's come from the retimer chip, but I've checked all of the voltages on these as well in diode mode, and they check out with a working board that I've got, so there's no problems there. There's no shorts in any obvious places that I've been looking at. I checked all of the MOSFETs down here. I've got 2 more plays left, and other than that, I have no idea what to do. I've also checked out in diode mode all of the readings on these little resistors here. They seem fine. The only other things I've got to try are replace U9F1, which is this little chip here. I think this is the RAM IC, and also the HDMI port. Again, I've checked in diode mode every single pin, but we have a discolored pin here, and I don't know why that be. I've also taken the multimeter and checked in continuity mode to see if any of these are touching to be able to create that short for when we're turning it on, but they're not. Inside the port looks fine. So my play is to remove the HDMI port. I'm going to do that first, and also replace this little chip. Okay, HDMI port removed. Any difference? Let's have a look. still exactly the same. Let's replace this little RAM chip down here. I have just replaced this chip and the soldering looks absolutely fine, so we're going to test it now. Wish me luck. Ready? Oh, I thought that was it. I thought it was staying on. We fixed the initial error by managing to actually turn on the Xbox. We removed the HDMI port. We replaced this U9F1 chip down here. Standby voltages are fine. I've checked the whole board for heat and there's no heat with the flare cam. Retimer chip replaced. Almost checked every single capacitor on the board for a short, but nothing. I'll put this one to the side for a stream because I know that people watching will perhaps want to try and help me fix this one. So if you do think you know why this might be happening, please feel free to leave it down in the comment section below. I'll make sure I take note of the serial number and put it in my log to say what we've done today. Feel free to hang out with me on another video. I'll leave it in the card in the top right, and also the video should pop up any second now. Thank you for watching. Sorry I wasn't able to fix it, and I will see you in the next one. Peace.